Okay, this is a video for chapter 11, part 1. We're going to continue with statistical diagrams. And this time, we're going to be focusing on dot diagrams. So let's take a look at what this is. Now, a dot diagram will look like this. And let's take a look at some of the key points inside this dot diagram. So this is a representation where each value in the data set is represented via dot above that value on the number line. Okay, so number lines, we've covered that in Sec 1. Horizontal line showing us different values at different positions. So when a value appears more than once, the dots are stacked up. Now, the dot diagram will show how the numerical data is distributed on this horizontal number line with equal intervals. So as you can see, for this particular dot diagram, for this 100-meter sprint, we see the timings on the horizontal number line ranges from 10 to 11, and each interval is 0.1 seconds. There is a consistent interval for between every single number, okay, of 0.1 second each. This is for us to have an accurate representation, an idea of what the data is like. So we can, using this idea, we can determine whether the data is clustered around certain values or if it is spread out evenly. Okay, so now in this example, we see that the values of the data where the dots exist. Okay, so there is one particular timing of 10.1. We've got 3 timings that are 10.2 seconds. We've got 4 timings that are 10.3, so on and so forth. And then we've got 1 timing that is 10.7. We do not have any timings that are 10.8 and 10.9. And finally, we have one last timing, which is 11. So the values of the data, they're between 10.1 seconds and 11 seconds. So 10.1 seconds will be the minimum. And 11 seconds is the maximum. Now to recap, we learned range in the previous few lessons. So range is our maximum minus minimum. In this case, our range is 11 minus 10.1, which gives us 0.9 seconds. Now the data clusters around 10.4 seconds. Clusters tells us where they gather together. So we usually, you will see a peak, the highest, the most repeated data point. Okay, in this case, we have 10.4 seconds. That's the tallest. And we notice that, hey, generally the other points, they are found around this 10.4. So we say in a statement that the data clusters around 10.4 seconds. The data is visually, so really just looking at it, visually, data is grouped around 10.4 seconds. And then we notice that there's a gap between 10.7 and 11 seconds. The largest value, 11 seconds, it deviates considerably from the other values in this distribution. So we call this an outlier. It is quite far from the rest of the data, which all of them are clustered around 10.4. So perhaps if these are the times for one single athlete on different training dates, maybe on the date that he clocked 11 seconds, maybe he was ill, maybe he had a stomach ache. That explains why his performance is not consistent with the rest of his timings. And we call that an outlier. So let's take a look at the next example. We have this particular dot diagram displaying the scores of some students in a quiz. And the total mark of the quiz is 20. Before we go into the questions, let's just quickly try and understand this. We have one student who scored 4 marks. We have 2 students who scored 5 marks. 3 of them scored 6, 1 of them scored 7. None of them scored 8, 9, 10. and the rest of them, they passed because 20 marks is the total, right? So 10 marks passed. You've got 3 people scoring 11. You've got many students scoring 12, so on and so forth. And then we have an outlier over here. One lone person scoring 18, and that is the highest. Okay, so now write down the mode. In part A, we can see that the mode is very easily obtained from a dot diagram because the mode refers to the value that occurs most frequently. And in a dot diagram, it will be the one that is the tallest. So in this case, our mode is 12 marks. Please do not forget to write down your units. Now next, part B, to calculate the mean. Write down mean equals to, now we know that we're going to add everything up. So we try and make life a little easier for ourselves. Let's start with our 4. We're going to add 5 and 5. There are 2 of them. So frequency is 2, the value is 5. We're going to add 6 and 6 and 6. So 3 of the 6. And then 1 of the 7. None of the 8, 9, 10. 3 of the 11s. 1, 2, 3, 4, 5 of the 12s. 2 of the 13. 1 of the 14. 1 of the 18. And all these divided by the total frequency, the total number of dots over here. So we can count 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 19 students altogether. And our mean is 190 out of 19, which is 10 marks. So now, we want to describe the distribution of the test scores in 3 ways. So let's visually we see that you see the students that are broken down into generally 2 groups, or we call it 2 clusters. The first cluster is around 6, and we've got another cluster around 12. So perhaps our first point could be the data clusters around 6 and 12 marks. Now, what else can we say? We can talk about the range. We can talk about the minimum and the maximum value. So the data values are between 4 and 18 marks. We can also talk about the modal mark, or the mode is 12 marks. You can also talk about the outlier. The outlier, there is an outlier of 18 marks. So we've got 4 points over here. You can choose 3 of them to talk about. So think about this question. There are no dots above the values 8, 9, 10, 15, 16, and 17. Can we exclude these values from the dot diagram? Meaning, can our dot diagram look like this? So 4, 5, 6, 7. So we exclude 8, 9, 10. We move on to 11, 12, 13, 14, as well as 18. And then the dots above them, okay, there are 2 instances of 5, 3 instances of 6. We've got 1 instance of 7. And then we skip the 8, 9, 10. We move on to 3 of the 11s. And then we've got 5 12s. 1, 2, 3, 4, 5. Please make sure your spacing between the dots are also consistent. So for example, what I mean is that 3 dots, if you're talking about the height of 3 dots, they should be at the same level, okay? So that you have the correct pictorial representation or visual representation. So 2 dots for 13, 1 dot for 14, and 1 dot for 18. So can we exclude all these values from the dot diagram? So compare the original dot diagram provided in the question with this particular one. What's the difference? Is there anything that is misleading? Does our amended dot diagram paint an accurate picture of what the distribution is like for the test, for the scores of the students. So think about it. Now the next example, number 2, again, we've got 100 meter sprint for students in a particular group. And we notice that this is quite familiar. So how many students are there? Just count the number of dots. We see that there are 20 students. Find the range. Range, maximum, which is 11, minus minimum, 10.1. You get 0.9 seconds. Now they tell us in part C that the fastest 20% of the students, they qualified for a competition. Who are these 20%? They are the fastest. So they're best, right? Based on the context, the best students, the fastest students, they have lowest timing. This is compare this with test results. The best students will have the highest results. For example, the tallest students will have the largest height. However, the fastest students, they have the smallest timing. Okay, so 20%, 1/5 of them, 20% of the students. How many students? 20 students. So let us find out how many of these students there are first. So number of students who qualified will be our 20% times the total number of students. We get 4 students. We are looking for the first 4 fastest students. So we count from the smallest timing. And then this is the first student. Then we have the next 3 students who all clocked 10.2 seconds. Now, this is a total of 4 students. Therefore, our qualifying time. Okay, so this shouldn't be the minimum, the maximum timing. Otherwise, it doesn't make sense. The maximum timing to qualify for the competition is 10.2 seconds. Anything more than 10.2 seconds, they are out. Let's move on to part D. Part D says that the students who took more than 10.5 seconds, they need to run again. So what's the percentage of the students who need to run again? We need to find the number of students who belong in this category longer than 10.5 seconds. So 10.5 seconds is not counted. 10.5 is not more than 10.5. So look at 10.6 and above, we see that there are 5 students. So the percentage will be 5 students out of 20 times 100%. And that gives us 25%. So 1/4 of the students, they need to run again. Okay, now we have the same data presented on a pie chart. So find the angle of the sector representing students who took 10.4 seconds. Now the angle for 10.4 seconds, we have how many students? Let's count 1, 2, 3, 4, 5. We've got 5 students who took 10.4 seconds. So the angle will be 5 students out of 20 multiplied by 360 degrees, because the total will be 360 degrees. So 5 out of 20 times 360 gives us 90 degrees. That is exactly 1/4 of the students. So write down the model time. In a dot diagram, it is very easy. The highest, the one with the highest frequency, meaning the tallest stack. So 10.4 seconds. That is our mode. Mode equals to 10.4 seconds. You have to write down your unit. So next one is to find a median. Same format, middle position. So we have got 20 students. We add 1 divided by 2. So we have 10.5. The middle position is 10.5. We are looking for the average of the values at position number 10 and position number 11. So let us find the values at position number 10, position number 11. So you need to count. Position 1, you can start from the bottom. Position 2, 3, position number 4. Just be consistent. Position number 5, 6, 7, 8, position number 9, position number 10. Okay, we're interested in this. Position number 11. This is position number 10. Now, if you counted from the top down, it would not matter. You will still get the same result. So the position number 10 and 11, they both are 10.4. So the median, which is the average, 10.4 plus 10.4 divided by 2, you will still get 10.4 seconds. I'll spread out your units. And now part H, calculate the mean. So mean, continue with the same working. So we've got 1 of the 10.1, 3 of the 10.2, 10.1 plus 3 of the 10.2. We've got 4 of the 10.3. We've got 5 of the 10.4. We've got 2 of the 10.5. We've got 3 of the 10.6. We've got a 10.7. We've got 11. So all these divided by 20 of them. So you get 10.42 seconds. So now part I, which would be a better measure of the average. So please take note, when we say average, you have to consider mean, median, or mode. And then the question further specifies, hey, they only want you to consider mean or median. So now we have two values. We have both the median value, 10.4 seconds. We've got the mean value, which is 10.42 seconds. Both of them are representations of average. Both of them tell us roughly where the center is. However, the values are different because of the calculation involved. So to answer our part 1, which one is a better measure? We always take a look at the diagram again. Are there any outliers? So yes, turns out 11 seconds is an outlier. It is considerably far away from the rest. It deviates from the rest. We see that the data, all of them clustered around now 10.4 seconds, but this 11 over here, there's a gap. All right, so this is an outlier. The effect of an outlier on the calculation of the mean. So recall the mean, we will need to add everything up. We will need to add this value of 11 in the calculation of our mean, and then we divide by 20 students. So the effect of this 11 is that it actually pulls the mean up. Now, if we consider the median requires us to find the middle position. So we are not too concerned about the largest value, the outlier's value. We are concerned about its position. We are concerned about the position of the median, rather the middle position. So once we have that, we can read off the value for the median. And we are effectively, when looking for the median, right, we cancel away the extreme values. We cancel away the next value, cancel away the next value, another value. So we are saying going from the bottom to the top, cancel, cancel. And we are left with the center values, right? We take the average of these two to find the median value. So by doing this crossing out, we are just going to ignore the value of the outlier. But we noted that there is one large value over there. So to answer this type of questions, we will always say the better measure of the average is the median. So how do we present our answer? We say that 11 is an outlier. As long as there's an outlier, the mean, the calculation of the mean will be affected. So what is the effect over here? The mean will be increased. So it pulls up the mean, and we don't want that. Therefore, the median is a better measure of, so use the phrases in the question, of the average. Okay, now part J, students in group B. They have a median of 10.5 seconds, a mean of 10.6, and a range of 0.7. So compare and comment on the timings of class A and B in two ways. So we can compare the median, we can compare the mean, we can compare the range. So we have options over here. Since we were talking about, we felt that the median was a better measure for the average in group A, we will continue to use median as one of our comparison. We will not want to use the mean, right? Because we already established that there was an outlier. We shouldn't use the mean. So we write down median of group A, which is 10.4 seconds, is lower than the median of group B, which is 10.5 seconds. The conclusion for this, now if the median for A is less than median for B, generally group A, students in group A run faster. Then in group B. Okay, so that is our first comparison. Our second comparison, let's look at the range. Range for A, which is 0.9 seconds, is greater than the range for those in group B, which is 0.7 seconds. So the conclusion, we say that the group A's timings are more spread out than group B. Alternatively, an alternative way of writing this is that group B timings are more consistent than group A's. Okay, so this is a keyword which you will need to know as well.